Hey guys, I just wanted to go over a few more things in terms of the manufacturing section of your NEA. So this is section E. Now this is great because it's actually now a really short section. It's only 10 marks and there's only a few things you really need to do here. So if we just check on the mark scheme again. So what they're looking for here is that you have correctly identified what they would deem appropriate tools and processes to put onto your production plan, and that you know what quality control processes would be necessary to make sure that they're done well, and then that really like the design of your idea actually has some sort of potential to be decent as a prototype. So the way that we're going to evidence it for the NEA without actually having to make it is by doing two things. The main one here, in fact, it's only really one thing to be honest, it's basically the production plan. If you can do a final rendering of your design, I mean, that's nice just because it shows the examiner at the end of the manufacturing plan. It's like, oh, look, here's my final design. Doesn't it look nice? But yeah, it's not exactly necessary, but yeah, that's potentially what they might want to see. Okay, so getting into what we actually need to do here. So here is the template for the production plan. You can literally copy and paste this template if you like into your portfolios. So the sorts of things that you'd be talking about here, you can see on the example one here what it could be written out like. You just write down the process description step by step. Now, if you're not sure on what you need to do for your product manufacture, you can just look in my YouTube playlists here. Like we've got manual processing. So that's any parts that might be handmade. So that's looking at using tools like saws and the lathe and drilling and sanding and things like that. So any of those hand processes first. Then the CAM one is all of the 3D printing processes we have, plus talking about things like the water jet cutter, the laser cutter, the CNC machine. And then the last one here is like the finishing process. You can see a ridiculous preview of me there. And that's talking about like, finish sanding and how to spray paint effectively. And things like that. And these videos will basically tell you what you need to write if you're just selecting those. So see these as being a bit of a plug and play. So you just think, right, I think to make this, I'm probably going to need to use this process, and this process. You just watch the videos from those playlists there, and then you can just start writing out a sort of procedure of operation into the table here. So just looking at the students here, this student has clearly done a sort of a very much a 3D printed based project. Now, this is one where if you do the entire project just as 3D printing, you do run quite a high risk of not really getting all the marks because they'll deem it's just too easy just saying 3D print. So they want to see at least some variation and some range of processes. So what they've got here, though, is they've broken down the process quite nicely. They've said, like, create the CAM model. Then you've got to export it as an STL. So you do that. And the video for that is on my playlist there. And then you've got to open the software in the open the STL in the CAM software so you can prepare it for 3D printing. And you lay it out, and then you put the material into the 3D printer, press print. Once the print is completed, remove the components by hand. Now, they've done this. This student has clearly tried to really draw out every potential piece of information they possibly can from this process because it's a little bit tiresome in its level of detail it's gone down to. It's basically because I don't think they've got any other process in their project, so they've just had to really fill this out. So this could really be condensed into export the STL file from the CAD system, import into the CAM processor and add supports and orient the model, load the material in, and then once the print is completed, remove support structure, and then you get into your finishing processes. Things like quality control, these are the things that will separate a top band production plan from a bottom band one. So the quality control is, how do you know that you've done a good job? Like how do you know that you've actually done a process sufficiently, and is it to the right level? So quality control procedures are really important. So it could be as simple as just getting a ruler and checking the size of something once you've made it. Or It could be checking against an engineering drawing, or it could be checking for, say, on a 3D print, could be just checking that the print has printed correctly and that the machine hasn't gone haywire. If you're spray painting, it could just be making sure you've got an even covering of paint everywhere. I mean, other things you can get into as well, it can be checking that a machine is working properly, and that it's not faulty. With the 3D printers I've got here, I always do just a little check, especially if I've not used the machine for a long time. I always just do a little check just to make sure that the filament, the plastic, is actually being extruded out of the machine first before I actually then start the print. And often you find there is something wrong, so you just have to correct it. So that's something that's really important. In terms of health and safety, they're looking for comments like safety goggles, extraction. So extraction is also called LEV, which is local exhaust ventilation. Using things like clamps, tying your hair back, wearing an apron, wearing a dust mask if you're sanding, knowing where emergency stops are, risks of burning your hands, whether that's chemical burning or heat burning. And making sure you've been trained on equipment properly and you're not just having a go at using, say, a jigsaw. Making sure that you're actually you've asked the teacher first to show you how to use it, for example. You're not just jumping in. So then really with this, just make sure that the processes are sequential, so they run step by step. You're mentioning any sort of specific key names of equipment there, scheduling. Scheduling. Don't be unrealistic. Like, don't say, 1 minute to do the 3D prints. 3D prints typically take 3 to 4 hours to do. So, those are just things to bear in mind. So once you've done that, that's pretty much the manufacturing stage done, to be honest. I mean, you can then do some fancy renders to finish it off, but yeah, that's basically it.